Welcome to Microlecture 22, where we talk about conformational analysis of cyclohexanes and specifically cyclohexane chairs. Okay, so what we've got here is a cyclohexane, and mine is already bending and puckering away, but if I try to hold it as flat as I can, what you see is that if I look down a carbon-carbon bond, and I have some of my atoms as white balls and some of them as red, but in any case you can see that they're eclipsing interactions, and that would be very energetically costly. So in order to avoid that, the carbons kind of move out of plane and thereby allow the hydrogen atoms or any substituents on the cyclohexane to not be eclipsing one another. So a great deal of strain is relieved by puckering. Now what a cyclohexane does is it folds up into what's called a chair. And it does all sorts of other interesting conformations, like it can do this boat conformation, and it can do twist boat, but you're not responsible for those conformations. The only one that you're responsible for is a chair, a cyclohexane chair, and so that is the most stable conformer anyway. And so how to get your cyclohexane into a chair is to handle any two carbons that are as far away from each other as possible, so maybe these two, okay? And then with one of them you're going to point it upward, and the other one you're going to point it downward. Make sure that the two bonds in the center are parallel with one another, and you have your chair conformation. So you can actually set that down on those three bonds that are pointed downwards. You can set it down on a table, for example. All right, and so what we're going to do is spend some time talking about all these positions around the cyclohexane chair and also how to draw this cyclohexane chair. All of the bonds that are pointed straight up and straight down are red colored. They're red colored atoms. And we've got the rest are kind of pointed around the periphery. So there's names for those. That's the axial positions that are going straight up and straight down. And the white atoms, the white colored atoms, are all around the equator, if you will. Those are equatorial positions around the ring. Another thing you're going to notice is that the positions are alternating up, down, all the way around the ring. So if the red colored atom is up on one carbon, then on the adjacent carbon it's going to be down. On the next one it's going to be up, so on and so forth. And so these are the things that we're going to show in our drawing of a cyclohexane chair. Another thing that I'd like to show you before the drawing is how to do a chair flip. Okay, so this bond that we had pointed upward, we're going to take that and point it downward, and the one that's downward, we're going to point that upward. Okay, so that's how to manipulate your model kit so that it undergoes a flipped conformation. And so what you're going to notice is that all of the axial positions are now bonds going to white colored atoms, and all of the equatorial positions are all red. So we're going to draw that as well. Okay, so now that we know what we are actually drawing when we draw a chair, let's go ahead. I'll show you how I draw my chairs. And this is just going to take a little bit of practice for you. But you'll get used to drawing them, and I would like you to focus on just having sets of parallel lines. So you'll notice that these two bonds are parallel to one another, and these two are parallel to one another. and then to complete, the structure, you've got a couple more parallel lines. I like to call this carbon atom that we pointed upward in the molecular model the nose that's pointed up, and I always start there as my reference point. So I always draw an axial up position on that carbon, and these are very precise bonds that must be drawn exactly this way, so you'll have to kind of memorize these positions. We could not draw that one axial downward, okay? That nose that's pointed upward, if you will, that has a bond that goes axial up. And then you can go around clockwise or counterclockwise, it doesn't matter, as long as you're alternating. Once it goes up on one carbon, it goes down on the adjacent carbon, and then up, and then down, and then up, and then down. So those are all the axial positions, and then in red I will draw the equatorial positions, which also alternate. These are drawn at an angle, so downward, upward, downward, upward, downward, and upward. And again, practice with this. So the ring flip is the next thing to learn. So here's my ring flipped conformer, and I'm going to go ahead and draw all of the bonds that were axial. They were done in black, okay? So I'm going to take those positions and draw them on the ring flipped structure. On the ring flip structure, the bond that was axial pointed up is now going to be equatorial pointed up. All right? And then we're just going to alternate again all the way around. Equatorial up, equatorial down, equatorial up, equatorial down, up, and down. And all of the positions that were equatorial, so those are the ones in red over here, all of these positions are now axial. So any position that was equatorial up is now going to be axial up. And so these axial positions are going to look like this. So equatorial up is now axial up. And what was axial up is now equatorial up. Okay, so when you do a cyclohexane chair ring flip, you are not changing the upward or downward orientation of the bonds. When axial goes to equatorial, if it was pointed upward, it's still going to be pointed upward. So axial up goes to equatorial up. Likewise, if a bond is equatorial up, when it does its ring flip, it's going to go to axial up. Same with all the downward pointing positions. We can't change an upward pointed position to a downward pointed position by doing a ring flip. So this is going to take some practice, just drawing out the chairs, memorizing axial and equatorial positions, and then being able to locate those positions in a ring flipped structure. In conclusion, this is what we have learned here. When you're drawing a cyclohexane chair, use sets of parallel lines. Never ever use wedge or dash notation with a chair structure. The positions are defined as axial or equatorial only. Be very precise with your bond angles and practice.